All right, thanks a lot. Thanks for inviting me. It's good to be here. It's good to be here in person. It's my first conference live in real life, so I'm very happy to see real faces. Usually the conferences I've been presenting at, it's been, cameras off, so it's very hard to present into the void, so it's good to be here. I hope this is interesting. I'm a research data scientist, and I'm going to be presenting a sort of research focus here. But I think there's going to be hopefully some benefit to everybody. I want to sort of draw attention to the importance of data used to build models, actually. So hopefully this is interesting. So I'm in the Advanced Analytics Division of the Bank of England. There's a disclaimer down there. I don't know if you can read, but it's important. If you're here to get some views from the Bank of England or its policy committees, you're in the wrong place. Okay, I'm a researcher. These are my own views here. So what do we care about? What is my research about? It's about understanding, anticipating bank risk of failure. And so this is a really obvious statement. Bank risk of failure is important. It sort of goes without saying. Something that we obviously care about as regulators at the Bank of England, but also, clearly there's a lot of interested stakeholders, customers, shareholders, directors. And we know from experience the social and economic costs of bank failure are very large. So obviously it's very important. It's been shown to be important in the output of research articles in recent years. So here's a graph. This is Google Scholar, top 1,000 results, articles which are looking to predict bank risk, bank distress, bank failure. That's the search term that I used. And so it's a near exponential increase. Obviously, science has been increasing almost in the same direction as this, but this just shows that there's a lot more research being done on this important problem. And a lot of this research is model-centric. So I've been reviewing a lot of this work myself, reading it. It's model-focused. A lot of it is running these horse races between different machine learning models and trying to answer the question, which one performs best? And that's obviously an important question and is the focus of the vast majority of these papers. What is less of a focus, and really actually something that's been neglected in this literature, is the data component. And obviously you need both model and data to answer important questions. The data is usually an afterthought in these papers. And really what I want to do also is analyze those abstracts of those papers. Actually, I just look at very influential papers here, more than 50 citations in sort of top journals. And I try to see what the abstracts are saying about data. So there's actually quite a few papers where there's no data mentioned at all. So the focus is models. There's a lot of papers where the focus is on financial data. I mean, that's the data being used. Financial data is obviously very important. Financial data, balance sheets, income statements, financial ratios are obviously key. And then a very small number of papers that look at non-financial data. So in those specific papers, it's on the structure of the organization. Those are some of the variables being included, or looking at some text around firms. So an example is actually my own paper. This doesn't have more than 50 citations, but I thought I would talk about it. It's my paper, Bank of England staff working paper from a few years ago. And this is exactly kind of the sort of the situation that you find in this literature. We compared a number of different models. We held the data fixed. We used financial information. And we compared models. And we found the random forest algorithm, very flexible, powerful machine learning approach, was the best. But we recognized that the paper had important limitations. And clearly, at the Bank of England, we have supervisors who regulate the banks and understand that financial information is not the be-all and end-all. They look at things like management and governance. They care about risk buckets and actually rate risk buckets around management and governance. Risk management framework is clearly an important thing in finance. Operational resilience, organizational culture. These are important areas of risk that supervisors care about. And so we noted, we only have financial information. We have, we're missing important data here. So really, this is about thinking about the sort of the range of data included in your sort of machine learning problem. That's what you should also be thinking about. When I talk about sort of a range of data, oftentimes like it gets confused with big data. Big data is obviously something that people want. We want to have more data. There's a lot more data out there. We would love to have a lot more data, but actually big data, and I just want to sort of just present a slide on this, is not a solution for everything. And actually there's something called the big data paradox, where big data might give you the illusion of confidence. It shrinks your confidence intervals just by the sheer volume of the data that you have. But it magnifies, if there is any bias in the data, it magnifies that bias. And that's really important. And this is a paper that was just published in Nature on vaccine uptake in the US. So obviously a very important question. And they compared different large N surveys. And they computed what they called the bias-adjusted effective sample size. And that's what this figure on the left that I took from the paper shows. So basically, they looked at this Facebook survey, a census survey, and from a polling company, Axios, Ipsos. And these were like 250,000 responses per week. And the effective sample size for Facebook was actually 10. So when you adjusted for the bias, they had a sample size of 10, basically. So we're thinking about the range of data, not necessarily big data. So I was talking to some people outside just before, and it does seem like there's a lot of people here with an understanding of data-centric AI, and that's great. From the sort of research community, that's actually, as I showed you in the sort of looking at the research articles in this space, it's completely model-centric. So it's nice to see data-centric as sort of something that is represented here. It's a sort of new movement. One of the sort of founders is Andrew. I don't actually know how to pronounce his last name. Andrew N. He is a leading machine learning researcher and entrepreneur. And so he spearheaded this data-centric AI, where actually we're thinking less about the models now. We've had a lot of innovation in modeling. And we're thinking more about the data that we're using for this model. The quality of the data, obviously very important. How to validate the data. How to think about biases that might be in the data. And so the idea here is we should develop methods to sort of standardize our thinking about data validation and quality. OK, so back to kind of like range of data. So here's a good example of thinking about other data which is absent and how that might be important. So this is a paper from 2017 and looking about trying to measure bank distress by using newspaper articles, financial newspaper articles. And basically, they held the model fixed, and they looked at how they might be able to measure bank distress. And here's the image of that, which actually corresponds quite well to when you would expect bank distress to go up to. So it's one of the rare examples of alternative data being used. A paper of ours really recently, Bank of England, is also kind of thinking about this from a bank risk perspective. So here we're not using, this was a kind of linear regression, causal inference type of research paper. We wanted to understand bank culture. And we wanted, that's a very hard concept to define, first off, but also to measure. And so the paper was both about measuring bank culture and leveraging data that we might call digital exhaust, unorthodox data, to measure culture unobtrusively. So we had 6 different sources of data and 20 different indicators. And in our regression framework, we found actually there is this relationship between culture and risk. So sort of bringing this all together now, talking about some ongoing research that we're doing at the bank. So where we want to vary the data set, hold the model fixed. We care less about the model. We care about improving predictive performance. So we want to vary our data. And specifically introduce non-financial data. So around management and governance, operational resilience, culture, those buckets, risk buckets that we haven't really been able to measure very well, but are clearly important. And we need to, if we want to improve performance, we need to be measuring these things. So here are the different sort of data categories and variables. So we have, of course, we also introduce financial data because that's, that is important. The typical CAMLs, capital, asset quality, liquidity, market risk. We get this from regulatory returns. We also then take data we have on management and governance bodies, board composition, structure, tenure, operational resilience, so the risk events and cost of those events in banks, the data quality of the data that we get from banks, and then in terms of organizational culture, whistleblowing, referrals, internal fraud cases. We have all this data, so we're just bringing it together and making use of it. And here's our sort of initial setup. We want to sort of have the exact same data set. We actually have the exact same number of variables for financial, non-financial, and then a combined. And basically, we want to sort of try to keep this kind of thing. This is what we want to vary. So we want to have a data set that's as close as possible across these different sets. And in terms of what we're trying to predict, it's risk of failure. We actually have what I call a problem with quotation marks. It's not a real problem. It's a problem from a sort of statistical learning perspective. We don't have that many failures in the UK to learn from. So we take, we don't have so much market data on many of our firms, so we take a proxy for failure, distance to default, known as the Z-score, and yeah, you just see the time series of the average Z-score since 2000. So it does look to correspond with periods of distress. So the lower the Z-score, the closer to default. Our experimental setup, so don't have to talk about the details so much, but we're keeping the model fixed as the random forest model, which we know is performing very well in this kind of context. And we're performing a rolling forecast operation here. So we're the picture here on the left, you see the blue is our training data, and we're predicting out of time, so in our red kind of dots, and we're expanding that window over time. And that's how we're going to measure performance, using a root mean square error. OK, so actually, some results now, and I'm close to done. Here, we're just comparing the performance of those 3 different data sets. We have on the x-axis the root mean squared error. The lower, the better. On the y-axis on the left is the forecast horizon. How far out are we predicting? From 1 to 4 quarters. And on the right-hand vertical axis, we have the improvement in percentage between the full and just the financial data set. So we just want to see whether we are improving our performance by including this non-financial data. And in fact, we are. Pretty much in every horizon, that circle, the blue circle, is got the lowest performance, the lowest error, except for in the first quarter, where actually the non-financial data that data set is performing the best. So even the financial data set on its own isn't necessarily better than this non-financial. So again, underlining this importance of this non-financial, this non-traditional data that we don't typically measure. We look at another outcome measure here as a sort of robustness check. So we look at also this supervisory score applied to firms, like how risky are firms. Supervisors actually put a number on that. And so we use that as the outcome measure. And again, we see a substantial improvement when we combine these data sets together. And so the right-hand side, the percentage improvement is from 4% to over 10% improvement, so quite substantial. So that's it, really. I hope that was useful and interesting. Really, what I want to focus on here was, refocusing attention on the data. Everybody's got important problems they want to answer, and oftentimes it's like, let's find the fanciest machine learning model and use that to approach the problem. And but you need model and data. And so really the data part is really important and been neglected. So we've taken a data-centric approach to predicting bank risk of insolvency. That's something we care about at the Bank of England, obviously. But this kind of thinking can be applied for many different problems, obviously, for any problem where it's a sort of supervised or even unsupervised problem. We've improved performance substantially when we introduce additional high-quality data around management and governance, operational resilience, organizational culture. Something I haven't really talked about very much is the quality of the data obviously, we have a lot of research which suggests, and a lot of subject matter expertise which suggests that these areas, management and governance, culture, operational resilience, are important. That's another important aspect of this kind of problem is having a theory and having a causal understanding of how data relates to outcomes. So I'll just end here. The work continues. There's more important data out there, and we're constantly trying to gather more. So thanks very much for your attention. I'm happy for any questions.